Welcome back to The Explainer. Today, we're staring down the National Brake reassembly and air gap adjustment process. When you're dealing with heavy-duty, industrial-grade mechanical systems, precision isn't just some friendly suggestion. It's literally the only thing standing between a flawlessly operating rig and a total catastrophic system failure. So, assuming you've got a clean workbench, your components are inspected, and everything is laid out in the exact order of installation, we're going to walk step by step through the standard operating procedures to rebuild this brake system. We're going to make absolutely sure that every single component is aligned, tensioned, and powered up perfectly. Here's our quick roadmap for the rebuild. We'll hit hub and disc stack setup, mounting the support plate, the critical air gap adjustment, wiring and torque, and we'll finish up with the restoring power sequence. All right, let's jump right into Section 1, hub and disc stack setup. Like I said, it is all about precision from the very first step. Okay, so first up, you have to position the hub on the shaft so that it extends just past the very last friction disc. But here is the absolute critical part. You need to verify that this extension is exactly 1/32 to 1/16 of an inch. Grab your feeler gauge or a dial indicator and get right on the hub face to confirm that tiny, precise measurement before you even think about tightening down those set screws. You might be wondering, is that tiny fraction of an inch really that big of a deal? Well, yeah. Miss that 1/32 to 1/16 window and you are in for a bad day. If you set the hub too far in, the pressure plate just completely bottoms out without actually clamping the discs. Your brake simply won't hold. On the flip side, if it's too far out, the hub is going to physically jam up the brake release mechanism. That tiny protrusion is the golden key to making sure the disc stack seats perfectly against the hub face. Moving on to building the disc stack itself. Say you're working with a 20 horsepower motor, you've got to start by dropping in that first friction disc. From there, you carefully alternate. Add a bronze stationary disc, then another friction disc, and so on. Always, always finish the stack by putting the bronze pressure plate on last. And here's a pro tip for you. As you build this up, gently rock each disc as you install it. You're feeling for a flat, secure seat right there in the housing slots. If a disc floats or tilts even a little bit, stop immediately. It's either out of position or it's damaged. Now pay close attention here. Those bronze stationary discs, they are indexed. They have very specific orientation features, like little notches or tabs, and those absolutely must align with the matching features inside the housing. If you just toss them in and ignore the orientation, you are guaranteeing severe binding, incredibly rapid wear, and eventually total brake failure. Go grab the photos you took during teardown and match that orientation exactly. Moving right along, Section 2, mounting the support plate, which is all about securing that solenoid perfectly. When you're bolting down that support plate with its 6 little socket head cap screws, the manual basically yells at you that the solenoid absolutely must be mounted vertically. But why? Why is that rule so uncompromising? Well, it's because gravity is literally doing some of the heavy lifting here. The solenoid relies on a natural downward pull to operate correctly. So if you mount it even slightly off vertical, you are guaranteeing erratic, totally unpredictable brake behavior. Actually, here's a quick trick. If you're installing a brand new support plate, throw a tie wrap on the solenoid to hold it in the released position before you mount it. If you don't, the internal spring tension will fight you the entire time you're trying to get it perfectly vertical. All right, we've arrived at the big one. Section 3, critical air gap adjustment. This is, without a doubt, the single most crucial measurement of your entire reassembly. Get this gap wrong, and your brake will either fail to release, fail to hold, or just outright roast the solenoid coil. You have to stay strictly within the allowed minimum and maximum thresholds. We're talking 1 1/4 inches up to 1 1/2 inches. That is a tight 1/4 inch window you've got to live in. But honestly, burn this exact number into your brain right now. 1 3/8 inches, or 1.375 if you prefer decimals. That is your preferred absolute gold standard for a flawless setup. That's the bullseye you are aiming for if you want optimal solenoid performance and maximum brake life. So how do we verify it? It's pretty straightforward. First, manually lift the solenoid plunger, let it drop, and snip away that tie wrap if you used one earlier. If the plunger doesn't drop all the way down freely, grab a small screwdriver and carefully lift the end of the clutch spring. Next, take your feeler gauge and measure the gap perfectly from the lower edge of the plunger straight to the top edge of the solenoid frame. Finally, press down and release that plunger a few times. You want to make sure there's zero binding, and it should fight you just a bit. You're looking for about 20 to 30 pounds of physical force to push it down smoothly. Now, what if you measure and you aren't at that perfect 1 3/8 mark? Don't stress, just follow these adjustment steps. Locate the stop tab up near the top of the support plate and loosen up those 2 small hex socket screws. Slide the tab up or down to tweak the resting height. Lock those screws back down, remeasure with your gauge, and just repeat that dance until you nail it perfectly at 1 3/8. Okay, the gap is dialed in. Let's hit section 4, wiring, cover, and torque. Time to seal and secure the system. You'll need to go meticulously down this electrical connections checklist. Pull up the labels and photos from your disassembly. Hook up the solenoid coil, the limit switch, and that space heater resistor. Double check that every single clip, grommet, and sleeve is right where it belongs. But check out that last bullet point. This is absolutely critical. Route all of your wiring as far away from the plunger travel path as physically possible. I highly recommend manually operating the plunger a few times while watching the wires. If anything even gets close to a moving part, reroute it right then and there before you put the cover on. Once you're certain the wiring is safely tucked away, we can button it all up. Pop on the outer cover and its gasket, making sure your releasing rod actually pokes through correctly. Snug down those 6-socket head cap screws, and finally, thread your release knob back onto the rod by spinning it clockwise. Notice I said snug a second ago? Well, that's not exactly true. Grab your calibrated torque wrench, because you need exactly 70 foot-pounds on those 6 cap screws. You need to hit that number to ensure the whole housing stays locked down tight under massive industrial vibration. Once you're torqued up, pull the release knob, turn the shaft with your torque wrench just to verify you've got the required holding torque for the leg, and then let go of the knob to re-engage the brake. Almost done. Section 5, restoring power sequence. Let's bring her back online safely. This sequence is a non-negotiable, so follow it chronologically. Step 1, restore power to your space heaters first. Step 2, restore the motor breaker in the jacking control panel. Why such a strict order? Because restoring those space heaters first immediately puts them to work fighting off marine moisture inside the motor and brake housing. You never ever leave a motor sitting in a harsh marine environment without its heater running, so keep your hands off that motor breaker until the heaters are absolutely live. And we have one massive flashing red warning before we wrap this up. For the hub splines and housing serrations, you use only Molykote 3402C. Never, and I mean never, let petroleum grease or oil anywhere near those brake discs. If even a tiny smudge of oil contaminates those friction surfaces, your brake is going to slip and the entire rig will completely fail to hold. It's game over. So I'm going to leave you with this final thought before you head back out to the shop floor to tackle this rebuild. Are your space heaters on? And are your discs absolutely, completely grease-free? Because the safety and operation of your entire rig literally depend on you getting these details exactly right. Thanks for hanging out with me for this explainer, and we'll see you on the next one.